to be given the medal, to be asked to speak here. As Simon and Garfunkel said in Central Park, it's great to come and do a gig in your hometown. So, so that's what this is for me, coming back here. Now, I must say, it's a bit tight being asked to look back 50 years. That would take me back to where I was basically 2. So, looking back on computing that far, I have to just imagine what it was like. I can more or less get the feeling that whatever else it was like back in the 50s, but certainly what I understood from Mum and Dad is that it was really fun and exciting. I think I get the impression that there was this feeling, I guess the moment Turing's result was sort of digested, that, ooh, with any computer, in principle, you can do anything. And therefore, that's a bit of a challenge. That means that if you can imagine it, then you should be able to program it. So the challenge, well, there's some programming challenges there, but there's also a lot of challenges to the imagination. And some people have felt that the connected set of computers across the internet poses a similar sort of challenge, that it's really, you can do whatever you can imagine out there. So developing the web and watching all the things that people have done with it has been a really exciting time for me, and I'm sure that more exciting things will come up on top of it. I'm going to tonight look back a bit, I suppose, at the process of making the web, but also look in general about what it's like to design things which become large systems, and design new large systems in the context of building on top of other large systems. Because the web itself now is something which we can study in its own right. So as Nigel said, web science, we realize that when you design something, you can't design it just as something which runs on a computer. You have to design it as something which runs in web, where the web is a web of people. So I'm going to start off, perhaps once I took a degree which was officially called experimental philosophy. Well, I'm going to start off by talking about philosophical engineering. I'll discuss a bit of the history of the web and the future of both the web and the semantic web, and wrap up. Well, and credit the talk throughout, really, with discussions of web science. So, experimental philosophy is physics. Well, that's, I suppose, reasonable. Philosophy is thinking about life, and then experimental philosophy is sort of doing experiments to find out about life, the universe, and everything. Then, surely what we're doing now, particularly with the semantic web, is we're building new worlds. We're writing computer protocols. We're writing the rules about how two computers communicate by defining a language, and the process by sending those messages written in that language across the internet. And as we do that, we're more or less, we're defining new logics. We're picking the logics which we're going to use. We're defining a world in which certain things are possible, but certain things are not. In which meaning could be ascribed to things in ways, more or less, that we define. So we are getting, if you like, now we are not just doing experiments, we are creating. We are engineering, we're building stuff. That's why it's very fun. And so, if you like, we're building philosophical spaces. The semantic web is a sort of philosophical space. And what's interesting for me about that is that what we actually design is the way two computers interact, or two people are allowed to communicate by blogging, for example. But the effect of that is definitely microscopic behavior. And so what's fascinating, the continuing theme, is the connection between the microscopic level design and the macroscopic. There's, in this thing, what we call web science, science in the social science sense, or the analytical, the normal sense of science, if you like, and the way in which computer science is. Computer science is really engineering. It's largely building stuff. And some people complain that the term word science shouldn't be used because it's so much about building stuff. So in web science we use it in both ways, because it's both synthesis and analysis. When you look at the web, a lot of people look at it with an idea of making it different, making it something new on top of it. But also, it's quite a complicated science to look at it, because the web itself is big and complicated it itself is an object of study. When you look at big complicated things that we look at, the population of the planet is about 10 to the 10, 6 times 10 to the 9. And that's the order of, the number of web pages is of the same order. So it's that, so you can get that level of complexity. When you look at the number of neurons in a brain, it's just about 10 times higher than the population or the number of web pages at the moment. Now, an interesting thing, of course, is the population of the planet is inexorably getting larger. The number of web pages is still on a rather gruesome exponential increase, it seems. But for most of us, the number of neurons in our heads remains depressingly small. So let's talk about this idea of designing a system. So we start off, when you're doing engineering, you start off with an idea, ooh, the better mousetrap. And if you design into computers talking to each other on the internet, you design technical protocols. You write down some specs. And those specs define how a system works. Well, they don't really, not on the web. Because the web, on the web, the internet and the computers are there to connect people, in fact. So there's always a social side to it. You're designing both social constraints and technical constraints. Designing something which will work and where people are expected to behave in a certain way. So the web was designing links, the technology to allow people to make links, and also recognize that people want to make links, that there'd be incentive for people to make links. And the result of this is that there is a system that you create. This system, when you look at it as a communication between two computers, or all computers, or any small number of computers, on the web scale, that is microscopic. It's a small thing. To physics, this is like the assumption that the gas is made of billiard balls. You assume